On May 31st, 2013, the atmosphere over central Oklahoma was a powder keg. Meteorologists knew a high-end event was coming, but no one, not even the most seasoned experts, was prepared for what was about to happen in a field just west of Oklahoma City. It was a storm that grew to a record 2.6 miles wide in seconds. It was a storm that moved in directions no one predicted, and tragically, it was the storm that proved even the most experienced chasers aren't invincible. This is the story of the El Reno Tornado. To understand the disaster, we have to look at the math. The atmospheric parameters that afternoon were off the charts. We're talking about convective available potential energy, CAPE, values exceeding 5,000 joules per kilogram. For context, anything over 3,000 is considered extreme. The dry line, a boundary between moist and dry air, was bulging right over El Reno. At 6:03 p.m., the first touchdown occurred. At first, it looked like a classic, manageable tornado. But within minutes, it underwent a rapid intensification phase that defied standard models. Most tornadoes are a few hundred yards wide. The El Reno monster stretched to 2.6 miles. If you were standing in the middle, you couldn't even see the edges. It just looked like the entire sky had dropped to the ground, but the size wasn't the deadliest part, it was the subvortices. Inside the main rotation, smaller, incredibly intense suction vortices were spinning at speeds measured by mobile radar at over 300 miles per hour. These mini tornadoes were orbiting the main center at highway speeds, catching chasers completely off guard. Because the tornado was shrouded in heavy rain, what chasers call rain-wrapped, it was nearly invisible. It also took an unexpected sharp turn to the north and accelerated. This erratic movement trapped several vehicles. Among them were Tim Samaras, his son Paul, and their colleague Carl Young, the Twistex team. Tim was a legend in the field, known for his safety-first approach and scientific rigor. Their loss sent shockwaves through the meteorological community. It was a somber reminder that nature doesn't follow a script. In the end, the El Reno tornado was officially rated an EF3. While its winds were measured at EF5 speeds, the rating was based on the damage to structures, and since it stayed mostly over open wheat fields, there wasn't enough damage to justify the higher rating. This sparked a massive debate in the weather community. Should ratings be based on what a storm does, or what it is capable of? Today, the El Reno event serves as a definitive case study in storm morphology and a sobering lesson in the risks of chasing. Respect the sky, because sometimes the sky doesn't play by the rules. If you want to dive deeper into the radar data of this storm, or see how the Twistex team changed meteorology, let me know in the comments. Don't forget to subscribe for more deep dives into Earth's most extreme weather.